So in this video we will see the this number of particle emitted during the beta decay process versus the kinetic energy relation, right? So basically the beta minus decay reaction can be written as follows. That means the neutron gives rise to one proton, right? One proton plus the electron, right? It gives one electron and then one anti-neutrino. This is the nuclear reaction that takes place during the beta minus decay process. So anti-neutrino, right? So which is basically during this beta minus decay process, the electrons are ejected in the nuclear reaction. So when you try to plot the number of beta particles emitted during the beta decay process versus their kinetic energy, it will follows in this fashion, right? It follows in this way. That means initially basically the y-axis is number of beta particles emitted, beta particles emitted, right? So beta particles emitted, and x-axis is this, right? X-axis is this. So and x-axis is basically the kinetic energy of electrons, so what happens, the kinetic energy attains maximum at this point. So that means whatever this is the actually the maximum kinetic energy of the emitted electrons, right? So this is the maximum, this is the point called as the end point energy, end point, right? End point energy. So at this point the kinetic energy of kinetic energy of electron is maximum, right? The kinetic energy of electron is maximum. So when you this is the basically the number of particles, beta particles emitted versus the kinetic energy of the electrons, the distribution curve for that.